Okay, so you're given a definite integral, but maybe you're not asked to antiderive it. Maybe you're asked to use a numerical approximation to find the area between the curve and the x-axis. Maybe in real life it's a function that's difficult to antiderive, or maybe you only have data to work from, so you don't have a function to antiderive. In any event, the AP Calculus exam will ask you for some numerical approximations of the areas between a function and the x-axis. For example, they may ask you to use something called the Trapezoid Rule. An example would be approximate the area between y equals x squared plus 1 the x-axis and x equals 4, all in quadrant 1. Use for trapezoids. All right, let's see what this means. Now, first off, you need to know what this looks like. You should at this point be able to graph a parabola that hits the y-axis at 1, goes up, let's see, over to 4. When we get to 4, 1, 2, 3, 4, I'm going to double my scale and go out to 8 here, make it easier to draw the trapezoids in a minute. We should put 4 in for x, getting 16, plus 1 is 17. On the scale I'm using on the y-axis, that would be 20, 18, 17 would be about there. So we're looking at the parabola that connects these 2 points. It's not all there is to the parabola. The parabola does continue symmetrically on the other side of our graph. It does go on forever, but we don't care about that part. We only care about the part from 0 to 4 because that's in quadrant 1 between x equals 0 and x equals 4. Okay, so we're approximating this area. Now this would be hard to find this area. Okay, you could antiderive it, plug in your values, but the question here is, can you do it with trapezoids? Now, the kind of trapezoids we're going to draw look like this. It's not what most people picture when they see a trapezoid, when they think of a trapezoid. Most people think of that regular trapezoid that's on its side. This shape is used for a particular reason. Now, the notation can get a little bit confusing. For example, by definition, on a trapezoid, your 2 parallel sides, so the only real definition of a trapezoid is only 2 parallel sides, are always your bases. Normally we think of bases as being parallel to the ground, the bases of a trapezoid. But in this case, the 2 parallel sides are up and down, so those are your bases. And your height of your trapezoid is always the distance between the 2 parallel bases. So, doesn't look like what most of us picture when we first think of a trapezoid, but this is a trapezoid. Only 2 of its sides are parallel. They're the bases. The height is the distance between them. It helps to also remember the area of a trapezoid equals, it's a couple of different ways you may have seen it written. I like 1/2 base 1 plus base 2 times height. That's the area of a single trapezoid. Now, if you've done anything with area and antideriving and integrals in calculus, you should be thinking about rectangles. That's what you're told to think about. That the area we're talking about, the area between the x-axis and this parabola is thought of as an infinite number of rectangles. But we're not going to add up an infinite number of rectangles like we normally do when we deal with the definite integral. We're only going to deal with trapezoids and only 4 of them. That's why this is going to be an approximate area as opposed to an exact answer. I'm going to draw my 4 trapezoids. Now, if I divide the space between 0 and 4, let's do a little better job of labeling that than I've done so far. If I'm going to divide the space between 0 and 4 under this parabola and above the x-axis into 4 trapezoids, 4 evenly spaced trapezoids, then this height of the trapezoid, I know it looks like a base, but it's actually the height because it's the distance between the 2 parallel sides, is going to be the same for each trapezoid. It's going to be 1 unit across. So here are, if you can see them, the 4 bases of my trapezoids, which are supposed to be right along the x-axis. One of them isn't so much, so let's take a moment and put it there. And now these trapezoids need their parallel sides. Here's one of them. Here's my first trapezoid sitting there between 0 and 1. Let me put some better labels in here too before I go on. This is x equals 1, x equals 2, x equals 3, x equals 4 I'd already labeled. Make another trapezoid going from the x-axis up to our curve. We'll make another trapezoid here. This actually looks like a better representation of the area than you'd think, but you can see, even with my horrible sort of sloppy drawing, the trapezoid's no longer lining up nicely with the parabola at a certain point. All right, so let's find the area of these 4 trapezoids and add them up. That's our approximation. So the area in the trapezoids will equal, I can use equal here instead of approximate because the area of these trapezoids I'm finding exactly. It's only an approximation because these trapezoids don't line up well with my parabola. It's going to equal the area of the first trapezoid. Now wait a minute, I need some heights here. I have to label some things. All right, we have each of these bases is a horizontal change. We usually call that delta x. So the height of every one of these trapezoids is delta x. These bases, which are now vertical, these bases start at 0 and they go up to some y value. Here, for example, is a y value I'm going to call y sub 0. Here's a y value I will call y sub 1. Here's another y value I will call y sub 2, y sub 3, and y sub 4. Notice that with 4 trapezoids, I need 5 y values. Okay, each trapezoid has 2 sides. They're sharing some of them, but 4 trapezoids, 5 y values. Now the area of my first trapezoid is going to be 1/2 the length of my first base, which is y initial, y sub 0, plus the length of my second base, which is y sub 1, times delta x, plus another trapezoid, which is going to be 1/2 the length of the base under y sub 1, plus the base under y sub 2, times my height of delta x, plus 1/2 y sub 2 sub y sub 3. That's the length of the 2 bases of my third trapezoid, times their height of delta x. I realize that seems like a weird way to use the word height, but it's accurate enough. And 1/2 y3 plus y4 times delta x. These are my areas of my trapezoid. And my approximation of my area under the parabola will be the sum of the heights of each of these 4 trapezoids. Let's take a look at this algebraically for a minute. Maybe I can neaten this up here on the second page a bit. Oh, wrong tool. And we are almost set. Okay. Let's switch to a slightly less bright color. So algebraically, notice something here. We've got all these areas that we're going to add up. We're adding up 1, 2, 3, 4 terms with some common factors. Every one of these terms has a 1/2 in them. Okay? They also have a delta x in them, but we're going to put that on the other side. Now let's see what else they have. If I factor out the 1/2 and the delta x is going to be way over here somewhere. If I factor both of those out, I'm just left with adding up the y initial plus y sub 1 plus another y sub 1 plus y sub 2 plus another y sub 2 plus y sub 3 plus another value of y sub 3 plus y sub 4. So this winds up looking like my first y value plus 2 of my second y value, because my second trapezoid shares a base with my first one. Similarly, I will get 2 y sub 2's, because my two middle trapezoids share a side, and I will get 2 y sub 3 values, because my last two trapezoids share a side, but I will only get 1 y sub 4 value, because that's where I stopped. Now, where do I get these y values? Well, I made these trapezoids the height of my original parabola. So y initial, y sub 0, is going to be f of 0, whatever I get when I plug 0 into my parabola, so that'll be 0 squared plus 1, or 1. Y sub 1 will be f of 1. So however high this is, this second base, however high that goes up in the y direction, and that will be 1 squared plus 1, so that's 2. Y sub 3, whoops, skipped one, y sub 2 will be the value of my function at 2, which is 2 squared plus 1, which is 5. Y sub 3, or f of 3, will be 3 squared plus 1, which is 10. Y sub 4 is f of 4, which is 4 squared, or 16 plus 1, which is 17. So the approximate value of my integral, the integral from 0 to 4 of x squared plus 1 dx is approximately, now I have to use the approximate sign because we know how to find this exact area. Otherwise, with through anti-deriving and through the fundamental theorem of calculus, but these trapezoids aren't going to add up to quite the same thing. It's going to, and this value will be 1/2 y sub 0, which we said is 1, plus 2 times y sub 1, which we said was 2, plus 2 times y sub 2, which we said was 5, plus 2 times y sub 3, which we said was 10, plus just 1 y sub 4, so my last number here is just 17, and this is times multiplied by my delta x. Now in this case, my delta x value is 1, because it went from 0 to 4 with 4 trapezoids. Won't always get that lucky, but sometimes the College Board is nice to you on the non-calculator problems, and your delta x is just 1. Okay, let's crunch this out. My area will be approximately 1/2 times 1 plus 4 plus 10 plus 20 plus 17. And that value is equal to 1/2 of 17 plus 20 is 37, 47, 51, 52, I believe. 17, 37, 47, plus 4 is 51, plus 1 more is 52, and that should be 26. So we've just used the trapezoid rule with 4 intervals to approximate the area between y equals x squared plus 1 and the x-axis in quadrant 1 out to x equals 4. Another thing that you might be asked is, how off were you? What was the error in this? Was this a particularly accurate way to approximate this area? Well, in order to answer that, you have to remember how to find the area exactly. So what you'll do then is you'll take your approximation and compare it to the exact area, which depends on your knowing the exact area from 0 to 4 between x squared plus 1 and the x-axis is found by anti-deriving x squared to x cubed over 3 plus anti-derive 1 to x. Fundamental theorem of calculus then says you plug in the endpoints of your interval, and this answer should be 4 cubed over 3 plus 4 minus 0 cubed over 3 plus 0, so that works out to be 0. This is 64 over 3 plus 4, which would be 12 over 3, which gives us 76 over 3, if I've done that correctly. So what was our error? Well, 76 over 3 is 25 1/6. This is the exact area. Our approximate area was 26. So for this method, our error equaled 5/6. We came up with too much area by 5/6 of a unit. That's an introduction to the trapezoid rule. It'll get you started. You may also find programs for TI calculators and other calculators that you are allowed to use on the AP exam that will manipulate the trapezoid rule for you. Just put in the function and the number of intervals, and it will handle this for you. However, with functions as simple as this and with only 4 or so trapezoids, this is a completely fair non-calculator question on the AP. So you have to know how to do the trapezoid rule by hand. That's it for trapezoid rule, and we'll go into this and other numerical methods in more depth at a later time.